now we're making our wine, and that's good. This is where the fun part becomes, because this is really the more active part of it. So I've gotten our elderberries, kumquats. The only thing I can't suggest doing is pawpaws. Don't try pawpaws, because they're really slimy, and it was a real mess when we tried that for somebody, so I wouldn't suggest that. Okay, I've got a certain amount of water in it. Let's say I'm making 5 gallons, so I've got 3 gallons, about three, almost 4 gallons of water in here, and I've got my elderberries, you know, frozen, destemmed, refrozen, thawed, put into my bag, and I've mixed in a little bit of sugar. And now I've got to figure out where I'm going to go from there. The first step is to set the sugar to get the amount of alcohol we want. That's the reason for the hydrometer. So now we're going to learn how to use the hydrometer. So whoever wants to volunteer from the table, bring the hydrometer jar and the hydrometer up here, and you get to help start. Now the cute thing about the hydrometer is, don't drop it into the hydrometer jar like that. You'll crack the end, you'll buy a new one. Put it on the side and just slowly, that's perfectly fine. All right, now what you want to do is come over here and use our nifty handy dandy straw thief. And by the way, you go to Europe to different wineries, they'll make these that are 4 feet long, made out of crystal. I mean, they're $1,000 a thief, and the master winemaker, boy, that's his badge of authority. Okay? They also make them in very risque shapes, so most of which are probably not legal in the United States. But all right, go ahead and fill it up. While you're doing that, then I'm going to put the slide back up so you can see what we need to be doing. I think it's back. There we go. Yeah.
When you make the elderberries in the bag, you put it in there and they're thawed out and all that good stuff. You don't have to lightly press it in any way?
No. Do not press. You don't have to do anything to it. The chemical action, the yeast action will take care of everything. And when we're getting our sample, the other thing is just move that to the side and take the sample of the juice. Really simple. Okay? Now, yeah.
You mentioned you want to put in the other as early as you can.
Yeah.
Have you
Yeah, see, the first time you do it, you're not quite certain how you're going to get there. The second time you do it, you can throw everything you did the first time up front. Just like the amount of sugar. You kind of guess you're going to have 2 pounds of sugar per gallon, so you put in 1.5 pounds per gallon right up front and dilute it, or dissolve it in the water, and then put your elderberries in and see where they go. See? So, now, how to read this nifty hydrometer. Remember the meniscus here. And secondly, after we calibrated it, but we're going to assume, just for today, they're all calibrated at 1. Okay? First thing, make certain it floats freely. Okay? And that's not always an easy thing to do, because you have to find a table that's level. So, you notice it tends to stick to the side. Well, you don't want it to stick to the side. So you've got to find a way to get that thing so it's floating free. Now, secondly, you're going to be looking at either specific gravity or potential alcohol. I use specific gravity. Murphy's Law says that whatever scale you want to look at is going to be on the opposite side of where you are. So, yeah, and it's hard to get it around there. Now later on, when you're fermenting and you're using this, you may want to tap it a little bit too to get some of the bubbles off, because that's an inaccuracy. You don't care, you want a general indication of where it is, so you're not too worried about those bubbles, okay? But, okay, so, like I said, some of these are, and that's why this is a great time to learn how to do this, because until you do it a time or two, it's kind of daunting. Once you do, it's really simple, okay? So go ahead and pass them around and make certain everybody's got something to play with.
Is that the sugar level? I was reading specifically. We got a wine there. So you got 2 scales on there?
There's 3 scales. There's the specific gravity, there's balling or bricks, which is percent sugar, and then there's potential alcohol. So you can use any of them, but if you say I want 12 and a half, you can do that. But I use specific gravity. It's a little more precise.
So which numbers represent what thing?
Well, if it says 1.0 something or other, that's specific gravity. You read the scale. See, it says specific gravity right there. Specific gravity, balling.
See, I'm looking up here.
Yeah. Okay, look right down at the, look right down here, and it'll tell you which scale you're on, you're looking at. Okay? Here, somebody's missing one, so let me give it over to
You
them.
didn't get one over there.
We didn't have one and
Okay.
borrowed it while ago, and I
Who's-
tried to give it back to them just now, but they didn't.
Here's another one to share around. Take a look at it. There'll be a test in a couple minutes. Yeah. Okay, what kind of reading are you getting? It's 1.0 something. Okay? 4.2? Who agrees with 4.2? Okay? Now, have you subtracted or added off for the meniscus? Did you do the reading at the top? Subtracted it down?
Yeah.
Okay? It's close enough. We won't want to do that's fine. But I want everybody to try looking at it and see how to read it. Because you can imagine if this gets much darker, you can see this allows you to see, by the way, that's maple flavoring, so this is going to be maple wine. It allows you to see both those things happening with that particular amount of color.
Clarification. So if we're reading it as a constant distance, we would add the .02 to it.
Right.
We're reading there.
You're really a little higher. The meniscus is lower in density than what the true liquid is. Okay? Okay, now, here's what's neat about this. And by the way, this particular chart is good for a gallon, 1,000 gallons, and 10,000 gallons. It works, okay? Now, you kind of, but it's not absolutely accurate, but it works really, really nice. You said we were 1.042, right? Okay? 1.0, where are we? Specific gravity, 1.04, well, we're right in between these two. We're between 10 and 11 bricks. Okay? If I wanted to go to 22 bricks, all right, which is really too high, and I don't suggest that, but that's how these things were done. If I want to go to 22 bricks, from there I would add 2.5 cups of sugar per gallon of wine to get to the right specific gravity. Yes?
So this scale is only to go to 22 bricks. There's no conversion to go to 18 bricks.
No. If you wanted to go to 18, subtract this amount off. So instead of 2 and 3/4, take off 7/8. So if I want to go to 20 bricks, you take off half a cup of sugar. Makes it real simple and easy. Now, again, this is a real good approximate thing because it gets you in the ballpark. Then you may need to tweak it a little bit later on, but at least get you in the ballpark. Okay? So according to this, all I need to do is add another, and by the way, that's the cups per 5 gallons of juice. Makes it easy for you. If you multiply that by 100, you can do 500 gallons of juice. Okay? This is also why, if you start looking at 13, 16, 20 cups of sugar, why weighing it out on a scale makes it a lot simpler and easier. Okay? A 2,000 gallon tank of wine will take, of elderberry wine will take about, let's see, it's 25, a little over 2,000 pounds of sugar, I think it is. You can imagine we have a lot of fun just mixing all that up. So, all right. So that means we need some more sugar, right? Okay. So what do? We again move this to the side, and this is where you kind of guess. With whole fruit, you have to guess a little bit more than you do with just juice. Here it's real simple. We throw it in and you stir it up. with whole fruit, there'll be a litter interaction. But what we've seen, especially with elderberries and most fruit, that sugar comes out almost immediately. And so you're really not, if you wait a day, it hasn't changed a whole lot. So what we're going to do is we're going to add some more sugar. So I take my handy dandy sugar. No, at this you can, but you don't have to. For sweetening, it certainly is. And it doesn't take a whole lot to get this totally finished, okay? Because sugar is extremely dissolvable. And believe it or not, we're not going so high that it's a real problem, okay? Now, I can't really see it, but you can feel it. Oftentimes you're doing this. And again, 5 gallons of stuff isn't all that hard to do. I don't know exactly how much water I've got here, so I'm going to probably overshoot, and that's okay. Okay? Now, everybody that's got the hydrometers, come back and do it again. Or send somebody else, preferably.
Do we pour that back in there?
Just pour it right on in. Yeah. You don't have to. When you sweeten it later on, it's handy. That's when it's really good to do. It's not. It just makes it dissolve easier, but you're diluting things more.
Well, that's like iced tea.
Yeah.
What I do is we just cool it down, make sure I don't.
Yeah. Yeah, I just use maple flavoring to. Yeah, because we're going to be drinking this in a little while, so go ahead and let everybody dump stuff in. Then that way we got about the same thing.
Make pancake syrup, cook it in.
Yeah, actually at a national competition, I judged maple syrups, maple wines at the time. This one from Canada, you just wanted a pancake. Just to munch on a pancake and drink the wine. It was really good. Yeah, that's fine. Okay. I just want to homogenize. Just dump yours in real quick and we'll homogenize it.
Question for you. If you were using other than sugar, meaning honey or a artificial sweetener, you would still use the same hydrometer?
No. You cannot use artificial sugar whatsoever because it will not ferment. And that's one of the neat things that sweeten back with that because it won't ferment.
That was going to be my question.
Yeah.
How do we do that, John?
Yeah, later. Yeah.
Thank you. Bring that up.
And honey, if I don't remind you, honey is 84% sugar. So honey, you do exactly the same thing, but it's going to take a little more sugar.
So we can still use honey at this point?
Sure.
But the artificial sweetener, if we want to introduce that, that's going to be after the secondary fermentation.
Yeah. Mm-hmm.
Per gallon. Yeah, so there's a chart.
And there's little tasting cups, good on the.
What's in that carboy?
Colored water. Just makes it easier for people to see when I do something.
So you're now introducing basically new sugar water to the wine?
Yeah, new sugar. Yeah.
Let it sit in there and let it fill up first.
That's the thing.
And you talked about that last gallon or 3/4 of a gallon that you have extra. Is that in order to get the sediment, the major sediment,
No,
out of the last carboy in a separate?
No, mainly it's, well, you want to get all your wine, and when it separates out, then you can siphon off the good wine. So yeah, it's a way to save as much wine as possible.
Basically the bottom part, right? Is you put
Yeah,
the last stuff.
well, you leave this and you siphon that off. We'll get to that in a little bit.
Because you mentioned it real quick when you talked about the extra that you had.
Yeah, the extra wine, you need a couple containers because you're going to eventually fill that and then let it sit for a while.
Yeah, you have usually even when you siphon it off, you get quite a bit of murky stuff.
Sometimes you do, yeah.
You got to go separately. Yeah.
Mm-hmm. Now I'm going to show you something handy here that works great for that too.
I never thought about doing that in a jug like that. I guess that's ideal because then you can watch it.
Yeah, yeah. Yeah, we're going to be close. Yeah, that's close enough for what we need to do. Just leave it in there.
Thank you. It's a bag.
I know which seminar I went to.
Okay, how are we coming on figuring out this particular number now? Where are we? 1082? Okay. Now, what I did was I dumped in twice the amount of sugar I had. Well, I already had some stuff pre-weighed, so makes it a little bit better. 1.082. I'm right up here around 20 bricks. We're done with that part. That's how easy it is. If you want to use honey or make a mead, honey is 84% sugar. You're going to have water in there. The other 16% basically is water and other insoluble stuff. So with honey, you're dissolving things down just a little bit. You'll need a little more honey. But yeah, you can use honey just like you would sugar. Both of these are fermentable. Artificial sugars you cannot use. There's nothing to ferment, which also makes it very nice if you want to sweeten it later on with an artificial sugar, like for a diabetic or something. They don't ferment, so you can just pour it right in.
If you understand the natural sugars of the, and I'm going to call it fruit,
Yeah.
added no sugar to it, but did your normal, all the other process with your usual recipe, you would have a very, very, very dry wine, or you would not even be able to get fermentation to occur.
Well, it depends on whose definition of wine we're talking about, but go ahead.
Where I'm coming from is, if you're dealing with the artificial sweeteners, only using the natural juice for the fermentation, and then after the secondary fermentation, add your natural sweetener, your unnatural sweetener, meaning your artificial sweetener, to then get the taste level of sugar you want.
Okay. By federal definition, anything more than 0.5% alcohol is considered an alcoholic beverage. Wine starts at 7% alcohol. Okay? Most fruit will not get you 7% alcohol by the natural sugars that are there. Apples are the closest thing, and sometimes you can get between 7 and 8% alcohol from the natural sugar from the apples, especially if you use a lot of Red Delicious. So you're not getting enough alcohol. The reason we add extra sugar, the yeast is consuming it. There's no sugar left by the time we get finished, because we're just using it to convert it into alcohol. Yeah. Yeah, so afterwards, so we're converting all that sugar, and then afterwards, if you want it sweet with an artificial sugar, just put that in to sweeten it up to taste. That's fine. Okay, what's the specific gravity now? Has everybody get a chance to look at it and figure out how to do it?
It's 8.
Okay, 1.08, right? Around that, pretty close. Because of course, the speaker always gets to cheat. I already had pre-measured sugar, so I knew where we were going to be. So, all right. So we're basically done with that. Yeah.
Couldn't you add concentrated apple juice?
You can add concentrated apple juice, concentrated grape juice, concentrated anything you want. Anything that's got sugar, that's a natural sugar. Yeah. Yeah. Of course, they're harder to get and more costly usually than sugar. So, okay. Now, remember, wine is something that's supposed to taste good. Now use the sample cups and taste what we've got. A little taste. Don't get too crazy, guys.
I assume you're talking about sampling the actual wines.
Yeah, I think that's going on too, yeah. Yeah. Okay, let's see where did I have alcohol, acid.
So what is the alcohol? What is the caloric value of wine?
Zero.
So it should be 0 calories.
See, the problem is a calorie is not a calorie. You have to define what it is. From scientific studies, the alcohol has caloric content, but your body takes it in and uses it to heat you up. So those calories don't go to weight gain. Only the residual sugar goes to weight gain. Okay? Right. Practically none. Okay, now, everybody's got that, you sampled that. What's it taste like? Sweet syrup, right? Okay? Yeah, this.
Oh, we haven't tasted this.
Yeah, taste that.
Okay.
You guys got ahead tasting the wine, so, okay.
It wasn't our fault.
But that's okay. All right, go ahead and try this mixture. It's maple flavored sugar water with a little acid, okay? I mean, I can tell you that right off the bat. Once everybody's got a sample, make it big enough that you can sample it twice, then bring whatever's left and dump it back in.
I know.
Yeah, you cheated. You took the hydrometer out. That's okay. Get this out of the way.
So your stuff on there, how would I know the difference? How much does elderberry, so many pounds of elderberry press out, so much juice?
Again, it's about 12 pounds per gallon.
Okay.
Okay?
How long has that wine been in that bottle?
I don't know. Why?
Well, I'm curious. It tastes like it's fairly new.
It is. It's probably 6 months old, something like that.
That old.
Yeah.
It's good.
Thank you. Okay, now that you've got the one sample, come back with the guys and get some more of our new improved sample and sample it. You don't have to measure it, just sample it. Because we've already set the specific gravity with the sugar. And now what I'm going to do is set the acid level. Okay?
So you've added something else to it now?
I just added citric acid to it.
You said to pour this back in there.
Yeah, it's fine.
Need the hydrometer, though, right?
No, you don't need a hydrometer. No, it's just a way to get sample over there. You know, you can leave the hydrometer out now.
Then I have to touch it.
I'm going to grab some more tea while I can.
What are you using for citric acid?
Citric acid.
Just plain citric acid.
Yeah, anhydrous citric acid.
Did you test the acid?
Yeah, we just did a minute ago. My tongue.
A question I was going to ask you a while ago. To feed your yeast, what can you use an organic line besides gum-ammonium phosphate?
I really don't know because I never worried about the organic side of things. To me, organic is a wonderful marketing ploy, but it doesn't do anything for people. And organic wines don't really sell outside the state of California.
There's no differentiation between organic and non-organic when it comes to elderberry.
But diammonium phosphate is considered organic. I think it's organic approved. Any of the yeast nutrients, because they're used up, they don't stay in the wine. That's the thing. Okay, so take another sample and try that. And compare the two. How many here liked high school chemistry? How How many did really well in college chemistry? Okay. Now that's where we start. That's where we start having fun here. First of all, taste these as I'm talking. We want to have the acid level in the beginning must somewhere around about 0.6 expressed as tartaric, believe it or not, even though it's not tartaric. This is just what the wine industry does since they were used to doing everything with grapes. So they measure, and we actually titrate the acid to be able to make certain where we are, and then convert that over to the tartaric scale. Now, that's a lot of chemistry work to do titration. I've got a several $1,000 setup that we do it on all the time because most people are not chemists. Most people don't have the chemical technique to be able to do it. And this is the simple stuff. You can buy an acid test kit. All right? And these are free, I guess. $6.20. And what you do is you measure the amount of acid by a color change. And there's a syringe in here and a phenolphthalein solution, and you titrate and come up with the amount of acid that's in there. That's great if you like playing chemist. Okay? Turns out your taste buds are as accurate or more accurate than this because you have to identify the color change. Now think about trying to do a red to blue color change in something as dark as this. It gets a little difficult. That's why we do it with pH meters in the actual winery. But your taste buds are incredibly sensitive to this and are really, really good. Was there a difference in taste between those two? Yeah. Did you see any more flavor or less flavor, or was it the same? More. As we get into the right pH range, it literally enhances the flavor. And it's because of how you taste, not because there's a whole lot of chemistry change here. It's your physiology is responsible for that. Okay? Describe what the second sample tastes like. Okay, it's got the fruit flavor, the maple flavor. Is there a little bite, no bite?
Not as much. I don't know.
Okay. Is there, it doesn't taste as sweet, right? Okay. Yeah, acid balances sugar. So you have too much sugar in something, you can add some acid and balance it out. Everybody here, have you had Sprite before? What does Sprite taste like? Sweet, but tart, right? Does this taste like Sprite yet? No, not quite. What you want is something that tastes like Sprite. Believe it or not, and we'll do that, in fact, show you how, normally we would measure it and do it by teaspoons and stuff, but we're just going to do something like that. Come back and get another sample and we'll try her again. So I'm not putting a whole heck of a lot in there, and usually it may take a couple tablespoons total, but this is why recipes cannot be followed, because every fruit will be a little different. Every batch will be a little different. And the amount of acid, the amount of sugar you need will be a little different for each one.
Am I pouring some in there?
Yeah, just throw it in. And just stir up. I'm not even certain where it is yet.
And what did you add?
Citric acid.
More?
Yeah.
Oh, okay.
But I'm trying to get it too far this time. That's it.
I made your berries.
Yeah, just stir it up and try some more. This should be about right this time.
It's a good way of showing all the ways that taste change.
That's why this takes a little longer, but I think it sticks with people better. Whoops. Yeah.
Is that acid blend that you put in there?
Now I'm using straight citric acid because, again, we're working with elderberries commercially. We can only use citric acid. So I buy it by the hundreds of pounds, so, you know, it's just like we buy sugar by the pallet, 2,500 pounds at a crack. You know. Okay, did you get the sample back for him? You need another sample. Yeah. Yep.
Okay, we'll try the one with that.
Right.
Okay.
Try it again.
Try it again.
I put some more in there.
So what goes through?
Sir.
So you just put acid in it, more acid in it.
Yeah, I just added more acid to it. Okay, so go ahead and try that. Now, that should taste pretty, at least to me, it tastes pretty close to maple Sprite. Sweet but tart, right? If we would take that into the lab, you're going to find the pH of that is somewhere between 3.3 and 3.5, probably pretty close to 3.4. We are so sensitive with our tongues that we can do that close of a measurement. So if you don't want to play chemist, you don't want to spend a huge amount of money when you're doing your homemade wine, do this. You add acid till it tastes like Sprite. Sweet but tart. You're in the right pH range. So you're minimizing bacterial spoilage. We're going to, when we finish the wine, you're going to do exactly the same thing, but you're going to add acid to kind of sneak up on it so that it has the best fruit flavor and doesn't give you a bitter aftertaste. And you just do that by trial and error, but that's the finishing part of wine. That so many people don't realize that's where most of the effort goes into it. This first part, believe it or not, takes about 2 weeks. The finishing wine can take years, okay, depending on what you want to do. Okay, so now that we have this, we've set the sugar level, we know what alcohol we're going to get. We set the acid level, literally by our tongue, which is really kind of handy because we usually keep our tongue around. Now if you didn't add it already, you can add the pectic enzyme, the yeast nutrient, etc., 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 the other things you want to put in there. The fining agents can be put in up front. They can be done afterwards. Typically, we do them afterwards only if we need them. Okay? Bentonite is for a protein haze. You have a whole bunch of different fining agents for different things. If you have a lot of extra tannin, we might use egg whites. And we want to soften things a little bit. They do that a lot in Cabernet, believe it or not. And it's literally nothing more than egg whites. If you ever had to make angel food cake and separate out eggs, that's what you do. Take a little wine, blend it up with it, and throw it back into wine. Okay? There's also commercially produced things that you can get. So, other fining agents, it depends on what it's for. You know, pectic enzyme, a lot of this is preventative more than anything else. We use oak chips to put oak into the wine and put some tannin into the wine. Tannin is an antioxidant. I don't want to taste the oak, and since everybody's been trying it, you probably could not taste oak in those wines. There's oak in every one of those wines. But it's below your threshold, and you really can't taste it. It's there as an antioxidant, yeah.
Just put chips in your fermenting tank.
Yeah. And for the amateur, you put them in right there during the secondary. Okay? So, once we put these things together, now we're going to put in the yeast. And for the beer brewers here, it's called pitching the yeast. That's what they call it. Because you just pitch it in. Okay? In wine, beer isn't quite that way either, but wine, you're going to do a little reading and read and follow the directions on back. How many people have ever made bread? Usually you hydrate that yeast, right? Yeah, same thing here. Follow the directions and hydrate the yeast. If you do that, it helps it along tremendously. You can just sprinkle it on the top, and about half the time it works and half the time it doesn't. A lot of your winemaking kits will tell you just there. Most of the time, you know, again, it's iffy whether it works or not. What you do is you take 104-degree water, put this in about 10 times the amount of water, in other words, half a cup, and just let it sit for 15 minutes and it'll bubble and boil, and you know your yeast is really active, and you drop it in there, stir it, and put your plastic sack over top of it and go drink wine someplace. Okay, that's all there is to putting in the yeast. It's really simple. Commercially, we have some other things that you can put in there. I like to, when they hydrate it in that water, I put a pinch of sugar and a pinch of Fermaid, the yeast energizer. Doesn't hurt all. It just gives it a little extra boost. Commercially, we have something called GoFirm, which is a commercially produced same kind of thing. It's just got nutrients and extra things to help it grow in the first few minutes of fermentation. If you have a stuck fermentation, in other words, everything's progressing fine, all of a sudden it stops, you've got a problem. Can you restart it? Sometimes yes. The best thing to do is drink it, or it's going to turn into vinegar. Because when you get a stuck fermentation, then the odds are it is going to start going to vinegar.
So this is when you invite all the neighbors.
You invite all the neighbors over and...
away, so they can't take it out.
That's right.
Drink
But
to
if
heart's content.
it's sitting there and they decide to, that's their problem. So, and like I said, there's three different. There's three basic yeasts that you're going to find at the winemaking store. One is for fruit, which is 71B from the Mulvane people, and I think it's Epernay from Red Star. There's Montrachet from Red Star, but K1 is for red grape, and then the EC 1118 is for white, meaning apple, white grape, anything very, very light. Now, if you've got a very light fruit that you want to bring out the fruit flavor in, use K1, 71B. And this is just one that's a stylistic, it's a choice, and you just have to try it a few times and find out. Like I said, we were working with a mead, just doing the fermentation on a mead, and the first 6 trials, now we're going to a whole different group of yeasts that we're going to try, because now we know we need a slow fermenter versus a fast fermenter. And it was really interesting. The fast fermenters tasted really bad, and the medium fermenters were sometimes good, sometimes bad. I mean, one was good, one was bad, but the slow fermenters were really nice. So.
This mead, you're actually using honey as your sugar.
Yeah. That was just honey diluted with water. 100% straight mead. I do a lot of wine judgings, and meads are very, very difficult. 1, to get a good tasting mead, but 2, to get a consistent mead, because there's 104 different types of honey, and those darn little bees won't keep going to the same plant.
Right.
And
the same cow, you wouldn't be able to.
Yeah, so the honey we get in the store is actually a blend, and it's mainly clover. But if I had one guy in the state that had some from milk thistle, and it tasted like light pineapple. So you can get a lot of strange flavor, but you just can't get enough of it to do anything with it. So, okay, so now we've got everything in there. Like I said, you put in the yeast. Now you're just going to have fun, hopefully. You put the plastic sack over it, keep the fruit flies out of it, and once every day or so, go down and stir it once or twice a day. Depends on how much of a mother hen you want to be to it. You can't really hurt it at this point. Go ahead and stir it a couple times a day. Perfectly fine. Measure it once a day to see how it's coming along. Because once you get down to around the 1.03 specific gravity range, now you see why it's important to know how to read this hydrometer, you want to transfer it to the secondary. And then we're going to put an airlock on it. Now, years ago, we heard a lot about balloon wine. People would transport it into this nice secondary and put a balloon on top. Great idea. The problem is, a lot of our balloons today are stronger than the jar. I had a friend of mine that did this, 23 years ago now, and he blew 5 gallons of wine all over his wife's new fur coat. He wasn't too happy about that. What you're really trying to do is exclude the bugs and the air. So what you're supposed to do is put a pinhole in the top of the balloon. Okay, the top and the bottom of a balloon are not under tension whatsoever. You can put a knitting needle through a balloon, inflate a balloon if you do it at those 2 points, and you're perfectly fine. So you put a pinhole on top, put it on there. That's your one-way valve. And as it gets enough pressure, it just goes out, so it doesn't really hurt anything. Of course, the new higher tech version, which costs a sum total of $2.50. Okay, you remember that sterilizing solution I said with this potassium metabisulfite? You just pour that in here. Put this and this is what's called a universal carboy bung, right there, and it starts bubbling. When it stops bubbling, you're probably done, or you have a stuck fermentation. Hopefully you're done, okay? And that's a one-way valve. It lets the gas escape, but doesn't let anything else in. You'll actually see fruit flies will get into that, but if you use the SO2, it'll kill them, and you don't have to worry about it. So now we're going to monitor that, like I said, every day or so. Here, once you transfer it, and all you really need to do is use a funnel, just pour it in there, because trying to siphon when it's fermenting is very, very difficult. Okay? Because the carbonation, the carbon dioxide messes up your siphon all the time. Okay, there's my carbon dioxide, and there's the adding of sulfur dioxide. There's your Camden tablets, and this talks about, you want about 45 parts per million. You want to add that up front. It's just a preventative, it's an antioxidant. Okay? When you transfer to this secondary, you don't put any in there. You don't want anything to screw up your wonderfully working yeast at this point. Once this starts going dead, in other words, it's not bubbling anymore, then we're going to let it settle out. Yes, dear? Okay. And that's what you're going to start seeing something like this. Now that's just bentonite and water, so that you can see it stratified out. Now normally our yeast layer is not that thick, so it's usually about this thick, about 1/4 inch or so. At that point in time, it's nice and dead, and it'll start getting clear. Now, somebody asked you, how do you know when? It's called the flashlight test. Put a flashlight on one side, and how clear is it on the other side? The first batch, it's when you see this big thick layer. The second time that you're going to rack it is when you see that it's really clear through the flashlight test. Okay?
Clear as looking through the
Yeah, you can actually see the flashlight here. Looking at it, and I didn't have to think to bring a flashlight. Yes, I did. No, I didn't. It's in my car. Okay, great. Yeah, honestly. These new little LED, there, here you go. That might not be strong enough.
You don't think so?
I don't know.
No.
I made that kind of dark, so. Oh, here, let me, here. Well, nah, it's not strong enough.
Okay.
Let me give that a shot. As the yeast, I mean, you can tell down here, nothing's going to go through there. It reflects a lot, okay? Let me do it this way. But up here, you can start seeing it go through. Yeah, here we go.
Right now?
Yeah, that's fine, thanks. Now, this isn't clear enough yet for the second racking, but you can see how you can use a flashlight to see how the clarity is of your wine, okay? Another very, very expensive tool here to, okay? So, the first racking, every time you rack, you put in another 45 parts per million sulfite, okay? Why? Because you're introducing oxygen, and you've got to tie up that oxygen subsequently, or you're going to have too low levels, which is going to let you be susceptible to bacterial spoilage again. Okay? So now we're going to show you how to rack wine. Okay? So once this is done, because there's a few little bits and pieces that make it really, really easy. This is basically the setup. You need the tube, and you can see, especially we're using the 5-gallon carboy, this goes right down in there really nice. This just clips on. Nice part is that holds it in place so that you're not mixing up that layer down there and getting gunk in there. Okay? Now, a little hard to see what I did here, so you want to position this so that it's on one side, okay, and then you lock it in. And actually we're going to need to put it on the other side, as you'll see. Okay? Now, some of you might have seen me earlier. I started the siphon to go down into the, let's see, I guess I'll throw it in here. Right, right. That little cap on the bottom keeps it out of the sediment. And so you're drawing from the top of the cap. That's what makes that really handy. Okay? One way you can do it is you can sit here and suck on it, fill the tube, clamp it, put it down here and get it started. That's the siphon. The problem is sometimes it doesn't work too well and it slows down. Okay? That's why I like these little guys. One at key for, again, another $2.70. Positions your straw, the siphon tube, exactly where you want it. And to start the siphon, all you do is this. Okay? I colored that green, so that's all you have to do for siphoning. Okay? This would be another 5-gallon carboy, and you're just going to drain it in there and just let it go. If it starts to slow down, blow into it again. Okay? If you want to stop it for some reason, that's what the clamp's for. Okay? Now, while we're at it, since I've got that, when you want to bottle, another little nifty thing called the bottling wand. It's kind of a one-way valve right here. That goes okay. I don't know how I can do this without being in the way for somebody. There you go. And lift it up, it stops. So you're filling from the bottom, so you're excluding the oxygen. We do all sorts of things to try to stay away from oxygen. But that's how you bottle. Okay? Do what? Yes and no. If you want to, you can. If you're patient, you don't have to. Commercially, we do. Okay? Because we do a lot of different things. And that's why I brought some of the other equipment here. If you're going to use a filter, you need a motorized type filter. Any of the other filters don't work. Okay? They're going to cost you $26. This is a couple $100. So if you don't want a filter, just be patient. Get back to wine. Typically, the first racking, you're going to get rid of most of the sediment. The second racking, it'll be fairly, pretty nice and clear. That's when you want to rack, sweeten, and bottle all in one operation. Because we're trying to minimize the amount of oxygen, so you don't want to rack wines too much. Anybody see the movie Bottle Shock? Okay. You notice he racked his wine 6 times? Okay. As I was telling the other night at dinner, the effect of bottle shock is not what was in the movie. Bottle shock is the addition of the oxygen, and it drops the flavor profile for 2 to 3 weeks after bottling. Because in the movie, it was because it was done, he racked it 6 times, it was done so well that they excluded so much oxygen that it turned brown for a few days. Now, that doesn't happen. Wonderful Hollywood, it doesn't happen. Because he would have had to transfer it under argon, a totally inert gas atmosphere, to do that. So really we're dealing with the oxygen. And we're just trying to exclude out as much oxygen as possible. But the bottle shock is from that oxygen. A lot of the gravity filters they have, I had one that took me 8 hours to filter 5 gallons. And I said, there's got to be a better way. So, I mean, you can rig up some stuff. You can use little pumps and this type of thing. But you're still to the point, you have to have some sort of filter media. And this is just a miniature of what we use. Ours, though, are $6,000 at a time instead of $200 or $250 or whatever it is. This works really nice for 5 gallons. Try to do 25 gallons. It begins to get a little warm, so you need to let it cool off for a couple minutes before you go on. So yeah, you can filter, but if you're just patient, you typically don't need to. Now, if you're going to send your wines to a competition, you might want to, but they don't really care about that. It's not that a little cloudiness in an amateur wine is not considered really a major fault. Yes, ma'am.
Could you filter it through a coffee filter?
Sure. It's about 6 hours for 5 gallons. And you're exposing it to oxygen all that time. Yeah.
On the adding of the sulfur dioxide, at any time will it affect the activity of the yeast, like even when you added it first? Let's say you add a little too much or something, are you going to foul up
If you add too much at first, yes. Because if you get over the 50, 60 parts per million, it'll start killing the cultured yeast. Our cultured yeasts are all SO2 tolerant. The wild yeasts aren't. But I can also tell you something about wild yeast. I have a friend of mine who does 16% alcohol Zinfandels out in California. She says, oh, I use the wild yeast. Now, privately, she says, yeah, let's start with the wild yeast, but it only goes for 1% or 2% of alcohol I put in the culture yeast because it just can't go that far. But that's her marketing ploy, so she wanted to say it had some wild yeast. Yes, sir?
So the SO2 is the thing that, quote, kills your wild yeast then?
Yeah, it stuns the wild yeast. Okay?
Is that 45 million parts per million, is that the part that's in the Camden tablet?
Yeah. Now, Camden tablets are 45.
Okay.
Anywhere from 30 to 45 is what you want.
You mentioned that once you rack it, you rack your wine into another crab wine.
Yeah.
You said you had the 45 ppm SO2. Is that per gallon?
Yes, per gallon. Well, it's 1 Camden tablet per gallon.
You didn't mention it this time, so I was wondering.
Oh, sorry. Yeah, it's per gallon. Or the powder, you do about a quarter teaspoon for 5 gallons. Okay? So you see, it's a lot easier to work with. Yeah, it is.
Do that each rack at the end.
Yeah. And you should only rack it twice. That's the whole point. You don't need to do a whole bunch. But you add that each time because what you're doing is preventing the oxygen that you're introducing from hurting anything. That's what it's really there for. And we will analyze wines that we get in from various people, and you'll find SO2 levels in because there's legal limits that we have to work within, and they'll be down to like the 3 and 4 parts per million. There's no protection for that. Organic wines have to have less than 10 parts per million sulfites, and then I do not have to put it on the label that it contains sulfites. If you like an organic wine, buy it and drink it. Don't keep it. It's not going to store very well. I had one blow off my shelf, in fact.
How many parts per million kill fermentation? Can you also use sulfur to kill the fermentation?
You can, but you don't want to taste it. 200 parts per million, you can taste it and smell it. So you see, we're working in a very narrow range. I've had one guy called up and said, my wine just isn't fermenting. So we went through everything. I said, well, put in the right amount of sulfur dioxide? Oh, yeah. A quarter teaspoon per gallon, right? No. So he said, what can I do with that? I said, well, either throw it out or dilute it a lot. And, you can do that. Some of your fresh juices, if you happen to buy juice in from places, will have certain sulfite levels in it because they pack it in there. And unless you know how to measure it, that's a problem. This is one of the major problems in commercial winemaking for small wineries. If you didn't make an A or a B in college chemistry lab, you don't have the analytical technique to measure the wet chemistry necessary to measure this accurately. Okay? So what do? Well, for the amateur, they've got a thing called titrettes, which uses a similar type of thing. You just break it off and pull, and it has a little vacuum in it, and it pulls a sample up. Problem is, they're only good to about plus or minus 50%. Again, not good enough for a commercial winery. It'll tell you if you've got SO2 in there or not. That's about it. So they're not real handy, but sometimes you want to know if, like we're testing juice, we'll use it for test juice, see if there's something there. That's why if you stay with the procedure, you'll be in good shape, because we've actually measured that all the way down along the line. What I do, because I don't have time to do all the measurements, I spent almost on a computer-controlled auto titration setup. It does any one of 14 different tests. I can teach everybody in here in 10 minutes how to run it. You draw it off a sample and you put it on the platform and you hit the button. And the computer does everything else. So, but most people don't go to that extent, but we know exactly what our wines are doing and how stable they are and things because we can perform those tests. Most people don't. We've actually had commercial wines that were so bad, this is at the Indiana State Fair 2 years ago, the judging panel, we had to go Benadryl because they were reacting to so much sulfur dioxide. It really burns your nose. Okay, so that shows you how you bottle. Now the question becomes, what do you use to close it with? Okay. we use all Stelvin screw caps. That is the absolute best closure for wine. I cannot recommend amateurs ever using a cork. Cork's the bark of a living tree. It takes a cork tree 50 years for the first harvest to bark, and then every 15 years past that. Anything that blows by during that 15 years gets included in that cork. If you take cork today, you can do a liquid chromatograph on it, you can actually see automobile pollution in the cork. Guess what leaches into your wine? Whatever's in the cork. There's 380 some different molds and bacteria in there they can't sterilize out. Once they take that cork and strip it off a tree, they leave it in the forest for about up to 18 months to dry. If it gets a little bit of mold on it, which they may not be able to see it even, when they take it in and process it and clean it with a chlorine solution, they get an element called trichloroethylanisol formed, or TCA. This is what we call a corked bottle of wine. That's where it comes from, is a bad cork. 10 years ago, 1 out of every case was corked. That's how prevalent it was. Today, with the advent of artificial corks, they're better. You don't have nearly as much. We're down to maybe 6% or so. And also, with the explosion in the wine industry, you can't get good corks. Amateurs never get good corks, unless you're willing to spend money for 10,000 at a time. As a professional, I have to buy them 10,000 at a time. Once I crack open the box, I have 3 weeks to use them, or the guarantee's off. Now, I don't think the amateur is going to use 10,000 corks. That's 2,000 gallons of wine, in 3 weeks.
What about synthetic corks?
That's what I say. The synthetic corks are fairly reasonable today. But for most of the amateurs, first of all, why a cork? It's not really a good closure, and it's a very inconvenient closure. You have to have a special tool to put it in, and you have to have a special tool to take it out. Now, if you're really enthralled with the pop, going when you open the bottle with a screw cap, The nice thing is, let me grab my bottle here. You still see an awful lot of corked bottles out there, okay? And the reason is, you can get used corkers for $500 to $1,000, and a Stelvin head to put on those things is $25,000. So this isn't a cheap industry to be in. That works perfectly fine. Okay, and if you have really any trouble, you can put them in with a rubber mallet, and you pull them back out. Those are called bar tops. Now, if you're going to age your wine for 5 years, for whatever reason, then you would want to put in a regular longer cork. But otherwise, that's perfectly fine. You can get regular screw caps. The lids are 5 cents a piece. These things are getting up to about 50 cents a piece. So are regular corks. Even the synthetic corks are getting up that way. So they're just more and more expensive. A couple other neat pieces of equipment. When you start, you're going to get these bottles given to you someplace typically, right? You're going to have to clean them. All right. First thing you want to do is rinse them out. This is called a jet rinser. Attaches right to the faucet. You put your bottle on here, and it streams a jet stream of water into the bottle. If you can't clean it with this, throw the bottle away. This works, by the way, for this bottle, and that bottle. Works great in baby bottles too, by the way. Like I said, if you can't get it clean with this, just throw the thing away. Now, the second thing is, then when you're getting ready to do you rinse them out, then you want to sterilize them. Remember the SO2. All right, you take your SO2 water and pour it into this guy, and since I don't want to have to pour everything out, you just put the bottle over top of this and press down, and it puts a spray of your sterilizing solution inside the bottle. Then you go back over to the sink, rinse it out, put it on the drying rack, which I think is down here somewhere. Yeah, and that just holds the different bottles to let it dry. Okay, you can do this and immediately bottle, or you can do it and wait 24, or if you want to rinse them, you put them on the rack, wait 24 hours, and then bottle. Either way works. When you start doing several hundred bottles at a time, these kind of things really, really help out. When you're doing 12, it's not a big deal. And by the way, a case of wine, 12 bottles, is 2.4 gallons. So 5 gallons is 2 cases plus a bottle. Okay? And the other neat thing is, where's 5 gallons on this jug? Anybody hazard a guess? You'd think maybe it'd be one of these rings or something. It's right there. That's actually 5 gallons. So if you fill it all the way up, like you should, to keep the oxygen out, you've got more than 5 gallons. So that's where some of the extra comes from too. Okay, so now, and you can see how this, in fact, let's just stick that in there, see if I can really mess things up. This siphon tube actually works for gallon jugs too. You just run this down, and you can see how this could kind of stay out. If this is the right thickness, it'll just stay out of that. But you can hold this over, and you can start your siphon by blowing that into the gallon jug. So it's a really, really handy thing to have. Okay.
I got a question.
Yeah.
I heard that elderberry wine, the older it gets, the better it gets, at least for about 3 to 5 years. What is that?
Well, that's about the same thing as saying any wine, the older it is, the better it is. It's absolutely false. An older wine's an older wine. It's a different wine. So you have to decide where you want your wine. And how we, the style in which we make the wine, how we start, the things we work with, dictates the aging schedule. And in a commercial winery, when you run out of one bottling, that dictates how soon you do the next bottling. So, but in general, no, you don't need to, if you do it right, because we're looking, this style where we make our wines in is what we call fruit forward. You want the fruit flavor. You want it as fruity as possible. The older it gets, the less fruit flavor there is. You get a 10-year-old Cabernet or Elderberry or whatever, the fruit flavor begins to dissipate. And you start tasting a base, what they call vineyard flavor in grapes, which is kind of a grape dirt and other flavors in there. If you like old aged wines, then that's a good flavor, then it's a good thing to do. The flavor doesn't improve much past the first 6 months. Most of our elderberry wines between 8 months and a year old when we release it for sale. It really doesn't go much further than that. Now, there's a couple wines that we're doing that are oak aged for 6 to 9 months in oak, and then they do it. But the more tannin, the longer you have to age it. So it depends on how much tannin and where. So it's a very, very long, drawn-out discussion.
The tanning, the aging process that takes care of the tannin, is disintegration in itself, or is it settling out?
No, mainly it's an integration and some settling out. You know, in a 10-year-old wine, you're going to have sediment in that wine. As it has aged, it's a chemically unstable system. It's going to change slightly with time. Now, the other thing about the bottle here with corks, with a natural cork, you've got to keep it wet, and you've got to keep it on its side to keep it wet. You also need to keep it with a constant, stable temperature, because every time the temperature changes or the pressure changes, that cork goes in and out imperceptibly. What happens at the same time? Oxygen comes in along that sidewall. So this whole mystique of, well, it's the oxygen transport through the cork that's responsible for aging the wine was absolute nonsense. You know, we've gone back with science and proven that doesn't work. Barrels. You do not need oak barrels. You need the oak. The barrel does not do what the popular people think that it does. In other words, the oxygen transport through the wood doesn't happen. You do lose fluid, liquid, and what you need, and you end up topping that up. Well, when you open up the bunghole, what goes in? Oxygen. That's where the oxygen comes from. So, other questions on that part? Yeah.
Could you comment just a little bit on how you use oak chips?
Yeah. Today, actually 20 years ago, the only way to get oak tannin into wine was an oak barrel. Today we have high quality toasted oak chips that are just like the inside of the barrel. And they're about a ½ inch in size. And what you do, like in the secondary, I would put them in right in the secondary as it's fermenting. No, oh, absolutely not. just throw them in, okay? It takes about 3 days to extract most of the oak, so you can actually tailor make your oak, and that's the neat part for our wines. We can put in French oak, we can put American oak, we can put in Hungarian oak, medium toast, French oak, light toast. I mean, there's all sorts of flavors that we can add in there, and it's literally like putting together a sundae, you know, and you finally get the mixture of all of them.
How much oak you put in?
That all depends. If you want it under the threshold, let's see, if I remember correctly, to give you, come back to this deal, you'd want no more than 15 grams per gallon for elderberry. Elderflower, it's under 5 grams per gallon. So, you know, just dump it in there and let it go. And again, you can add, if you want to err on the side of too little, because you can always add more. It's kind of hard to take it out.
You mentioned the oak chips you put them in, and they manage to come out in about 3 days.
Yeah.
Do you remove them after that, or you just leave them in there?
Either way. I mean, if you want, we typically here will just throw them in, and they'll waterlog and sink to the bottom, and when you get around to racking, you just throw them away. Actually, they make really good wood to put in your smoker for smoked meats. But, yeah.
What about the grape tannin?
You can add a lot of these things. Grape tannin tends to dry the front of your mouth. Oak then dries the middle of your mouth and the back of your mouth. So in grape wine we have both, and that's what we call the balanced palate. It's when you have the oak tannins across the entire mouth. Yeah, so you know, you can add some in there. You can also add tea. In a lot of recipes, they'll tell you to put a little tea. The same thing as just putting tannin in there. Tannin is an antioxidant, helps you store. Yeah. So, Edgar.
How do you work with the elder flowers?
Oh, very carefully. Again, we destem them, and you put so much. It's just a flavoring component, just like I put imitation maple syrup in here. Same story. Be the same way I did that. Coffee wine is made the same way. You're going to add acid, you're going to add sugar. It's just the flavoring component. And you have to figure out when to pick them, how to extract the flavor. I mean, you get a different extraction if it's with an alcohol. In other words, if you fermenting at the same time, or if you extract it with water. How long do you extract it? What's the concentration? I mean, there's a lot of things that go on, and whatever you start with is not necessarily how it's going to finish. And so there's a lot of iteration there to come up with the right formula. So it takes a while. But it's just a flavoring component, just like the oak is a flavoring component. That's why I say, if you begin to think about wine as being these 5 things, you begin to understand where you get all those 5 things. Believe it or not, most of you now have a better understanding of basic winemaking than most Davis graduates. Because they're actually taught how do you make wine out of vinifera grapes. So they start way off over here. They don't have to worry about these other things we have to worry about here.
A lot of these things are, some things are water soluble, especially in the plant. Some things are water soluble, some things are alcohol soluble.
Yeah.
So by leaving it in, leaving the must in there, for I guess some extended period of time, could extract more of the.
Yeah, and that's part of the technique and part of the iteration. You know, you try it one way 1 year or one batch, you try it another way the next batch, and you compare it and see. You know, I think I've got to figure out. See, we've done probably in excess of 800 batches of elderberry, and probably half of those have been different trials in the nuances, because you're not changing it a whole lot, so the average person will never see it, but we can, because we work with it every day. So there takes a lot of work on it. Okay, unless there's other questions, this, to give you an idea, that's looking right down into a tank, and if you can see that, that's boiling and churning, and that's what fermenting elderberry looks like. This gives you the idea that I should have put the slide up when I was talking about it. This is the wet chemical test for SO2. And that's my nephew, and I've taught him how to do it, and he's right about 1 out of 3 times. That's why we went to the other machine, because it's right all the time. And by the way, that little setup right there is $850. This is the little guy to be able to measure the alcohol after you finish with the wine. You know, for the amateur, starting with a specific gravity, you've got a good idea what the alcohol is. If you want to know it exactly accurate, it's this. And it's done by the difference in boiling point between distilled water and the material. Of course, I say it's this is actually $100, and the little slide rule that tells you what the result's $950. But the whole thing's a little over $1,000. But again, it's pretty. Hit the button and let it go, and once you've calibrated it, it's fine. That's called an ebulometer, or if you're from France, an ebulometer. And these guys actually made in France. There's our about almost $10,000 titration setup, and you see this is where the samples go. And it just depends on which one it is. Plus the nice part is, because of TTB regulations, we have to have all these tests on file. So this being computer controlled, we hit the button and it's on the disk, and we can pull it up anytime we want. Now, you want to bottle a little bit faster than that one little wand. This is the next step up. And that's close to $2,000. They do have some that are, I think, 4 head or 3 or 4 head. They're a little bit less, but not much. Gravity fill, you got to put your tank over top of it and then gravity fills, or you have to set up a pumping scenario. But you just put your bottles on here and they'll fill up to a certain level, and you take the bottle off and then go over and cap it. You can do about, they say, 800 bottles an hour with this. I've never been able to do it quite that fast, but okay. Then you've got to cap it, whatever cap you're going to use, label it, and then we have capsules. If you use a straight cork, oftentimes you put a capsule on there, heat shrink the capsule. If this was the capsule, you put it on the bottle of wine, you just hold it by one edge, and dip it in boiling water, move your finger, and it'll heat shrink right down. Well, it makes it look nice. So there's all sorts of neat little things you can do. Today with computers, you can make your own labels. There's plenty of labels you can buy at Office Depot and stuff to make your own nifty looking labels. Remember, it's amateur. You don't have to adhere to all the things we do in the commercial world, because TTB regulates every word on the label. Kind of fun. Okay, you want to get a little bit bigger. This is what we use. We have our descrambling table here that we dump cases of bottles on that. It goes through a rinser sterilizer where they're all rinsed and sterilized with ozonated water. This is the ozonator. It's on wheels because we use it a lot of different places. Comes into the filling unit, which rotates around and fills it. Goes over. It's the cap is put on and dyed on in place. Then we have a inkjet head that puts on the bottle date and a label, and then it's put back in a box. So 3 guys run this at 1,500 bottles an hour, and we use it every day. Our elderberry juice is produced on the same thing, elderberry juice concentrate. We have a steam generator back here in the back to a heat exchanger, so it's all done under stainless steel, all inert atmosphere, all FDA approved. Never had a problem with that. They just don't like labels. Let's see. Okay, last but not least, this gives you some of those weights and measures, because again, when you're dealing with these things, it's easy. It's for a gallon or 2, it's not too bad to get out a teaspoon. But when you're trying to do 20 gallons, it'd be nice if you could weigh it out, and that's what this does for you. Just gives you an idea of weights for the various materials. And again, you can see there's a whole bunch of things down through here that we can use. There's grape tannin. There's other different types of tannin. Oakmore is an oak tannin. So there's a lot of things that you can get from the wine stores. I have liberally taken from this particular book. And this particular slide is from Presque Isle Wine Cellars. They're a company up in northeast Pennsylvania on Presque Isle, island, which isn't an island, it's a peninsula, but what the heck. That's their phone number and everything. This is their catalog. They're really good for small wineries. That's what they're set up for, and for really, really, really ardent amateurs. You start buying a lot of things at a time. There's Cork and Barrel. There's various wine shops, various places, some of which may be able to give you help and some may not.